Welcome to homework.
The first step in problem 66 is to make a free body diagram. At point A, because at point A, all the forces are acting. So we have the weight of 200 kilograms straight down at point A, which if we multiply times acceleration of gravity, we get that it is equal to 1,962 newtons. We also have a applied force P, which we are solving for, as well as the angle alpha that it acts at. Then we have the tension in both of the cables that are going to point A from point B. And these tensions are also going to be equal to the applied force P, because it is a simple pulley, which means the tension in the cable on both sides has to be equal. So you have two forces that are equal to P going in that direction. Now looking at a triangle between points A and B, we can find that angle for the tension in the pulley between A and B, which I'll call theta, because we know both sides of this triangle given in the problem. So taking the tangent of that angle, theta, we can set equal to the opposite side over its adjacent side, and get that that angle is equal to 72.6 degrees. Now we know that we can sum the forces in the x and y direction to find the force P and the angle alpha. And I'll define x and y in this coordinate system. Now the sum of the forces is equal to mass times acceleration, but nothing is accelerating in this problem, so it's equal to 0. And we can also set the sum of the forces in the x and y equal to 0. So if I sum the forces in the y, I can set it equal to the weight of the crate, which is 1,962 newtons in the negative y direction, and then add up the forces from the tension in the pulley and the cables. So on the left side we have P times the sine of theta, which we just found to be 72.6 degrees. And since there are two cables pulling in that direction, you have to add them both. And then we also have, on the right side, we have our applied force P times the sine of its angle, alpha, to get its y component. And solving for P, we get that is equal to 1,962 newtons divided by 1.909 newtons plus the sine of alpha. And now we can substitute P into the sum of the forces in the x direction equation. Which is equal to negative P times the cosine of the angle 72.6 degrees for the cable running from A to B. And again, we have two cables going in that direction, so subtract it again, going in the negative x direction. And in the positive x direction, we have the applied force P times the cosine of its angle alpha. Now we can substitute in P from our first equation, the sum of the forces in the y direction. Now if we multiply each side of the equation by the denominator, we can get rid of it. Because anything times 0 is 0 on the left side of the equation. And they all have the same denominator on the right side of the equation for each force that we're adding and subtracting. So we're just left with the numerator on top. And now we just have one unknown that's easy to solve for, in the cosine of alpha. Plugging into my calculator, we get that alpha is equal to 53.27 degrees. And using that, we can solve for P, because using the sum of the forces in the y equation, we solved for P earlier to be equal to 1,962 newtons over 1.909 plus the sine of 53.27 degrees, which is alpha. And we get that it is equal to 724 newtons.